part 5 of the what is a limit lesson. We're given the graph of y equals g at x this time. Looks like a more complicated graph. And we're going to find each of the following limits if it exists. So again, we're using the same type of ideas. If you wanted, you could pause the video now and predict your answers and then play it again and see if you have them right. Use this as a test to see if you've understood what we've gone through so far. So the limit as x approaches -2 from the left. So again, I'd be approaching -2 from the left. I'd be on this part of the curve here. All my corresponding values are here. So I'd be approaching this hole up here, which looks like it's at 4. So the limit as x approaches -2 from the left would be 4. The limit as x approaches -2 from the right. Again, I'm still on this portion of my curve. Still approaching that same hole. So the limit as x approaches -2 from the right is also 4, which would mean that the limit as x approaches -2 of the function, since the limit from the left and the limit from the right are the same, would be 4. D is, there's no limit involved here. It's just asking what is the value of the function when x is -2. When x is -2, what's g at x? That's what that question is asking. So we look on our graph. We're going to go to our x being -2, and then we're going to look for the value here. Well, we notice we have a hole, which is not part of our function. Okay, we can approach that, but we can never actually have the value for. But we do have this filled in dot at -2. So the value of the function when x is -2 is actually +2. All right, moving on. The limit as x approaches -1 from the left. So x approaches -1 from the left. We would be on this portion of the curve, approaching this hole here at +1. If we're approaching -1 from the right, as x is approaching -1 from the right, the corresponding y values are down here on this branch of the function. So our function is approaching -3. The limit as x approaches -1 then of g at x, since the limit from the left and the limit from the right are not the same, we would say it does not exist, which you may use the letters capital D, capital N, capital E as a short form for that. You see that in textbooks. And then it's asking for the value of the function when x is -1. So when x is -1, the value of the function, we've got this open hole which isn't on, and it's closed in dot, so the value of the function is actually -3. Limit as x approaches 2 of the function. So limit as x approaches 2, so we have x approaching 2. Then our corresponding values would be on this branch of the function. So our function is actually approaching this value closed in dot here of -1. G at 2, so what is the actual value of our function when x is equal to 2? So it's going to be -1 as well. And the limit as x approaches 3 of g at x. So limit as x approaches 3. For the limit to exist, the limit from the left and the limit from the right would have to be the same, which we can test. We'd be on this branch approaching here. From the right, we'd be on this same branch approaching here. So the limit from the left and right would be equal and would be equal to 5. And that's the end of this part of our lesson.